apical impulse, and here would be additional one. So when you have two different pulsations, you could say that this is heart impulse or cardiac impulse, right?
But we don't find it.
We don't find it there, yes. We normally don't find it. The only way it would be when we have the hypertrophy of the right ventricle. Because normally the systolic function, the force of conduction of the right ventricle is much, much less than left ventricle. That's why we normally find left ventricle pulsation or apical impulse, but find heart impulse or right ventricle only when it's hypertrophied. Or when we have asthenic person. In that case, we also can find the cardiac pulsation or right ventricle pulsation. Only if asthenic, but he's not asthenic, right?
No, of course not.
For sure.
And then
So we just use the
The
hand.
other way how you can palpate cardiac impulse, because this is the Russian version, the international version, do you remember? Yes.
Second, third, fourth.
Your fingers would be in
Second,
the intercostal spaces, second, third, and fourth, like this. On the right side of the sternum, on the left side of the sternum, so, excuse me. So you try to find the pulsation, because it could be fourth or third intercostal space, that's why we put fingers into different ones. No pulsation, right, so we don't feel cardiac impulse, and this is normal.
okay.
So next pulsation,
Aortic
or
point.
palpation,
Aortic
Aortic
point.
aortic point, exactly.
Second intercostal space.
Second intercostal space,
Left side.
yes, and on the right side, very close to
Right
the
side.
right side of the sternum. Right side of the sternum, yes, aorta. Any pulsation?
No.
No.
Pulmonary.
Pulmonary point.
Pulmonary point. Any pulsation? No. When we have dissection, right, when we have less elasticity, there could be pulsation. Also it could be, we can check
Aortic
the
arch.
arc, yeah, with one finger or two fingers going like this, yes, very good. Do you find pulsation there?
Yes.
Yes, and this is normal. Perfect. And
Epigastric.
finally,
Epigastric
epigastric
lesion.
pulsation. Yes, you try not to put just on the skin, but you try to go down, you have to find this pulsation.
It should be
No.
no?
It could be found. We have two different pulsations. Could be found there two different pulsations. The which one? The abdominal part of aorta,
Yeah.
or when we
The
have the right ventricle, pretty large right ventricle. We normally find it here, right? But if it's enlarged, it can go like this, dilated right ventricle.
Okay.
And in this case, we would find what?
Epigastric part.
We could find this pulsation of the right ventricle over there.
I can actually see it.
How we can differentiate it?
location.
No, location would be pretty similar. That's why you have to differentiate whether it's abdominal part of the aorta or that's right ventricle.
Intensity?
No.
When does it occur? You need auscultation, the
You're very
stethoscope
I
there.
mean,
You wanna go?
integral, in terms of the...
Carotid artery. Carotid artery.
Uh,
When we have pulsation
In
of
the first
ventricles, it's very close with the central artery. You remember when we do auscultation, you put to find the first sound S1. It would be similar to at the same moment with the pulsation over arteric
Carotid
carotids,
artery.
right? The same thing. When we have the pulsation of the right ventricle, it would be at the same moment, practically the same moment, pulsation of arteria carotis. If it's abdominal part of aorta, it will take time for the pulsation to reach aorta.
Yeah.
So they would be different.
Oh.
Yes, integral.
Okay, so if I find pulsation in
If you find pulsation,
then we have
you
to check.
you check it with the arteria carotis.
Wait, if it's similar to the carotid aorta, then that means it's hypertrophy of the
Right.
That this is dilation.
Right ventricle.
Dilation. Dilation with hypertrophy. It's very hard because hypertrophy means that you find this apical impulse normally in the fourth intercostal space. But if you find it a little bit down, it's already dilation.
And if it's not similar, then it's abdominal.
Yes, then it's abdominal pulsation. So once again, in your minds, the amplitude or the force means hypertrophy, the force of construction. The size, the shiftness means dilation.
Okay.
Make sense?
Yes.
Okay, yes.
Look over there with the apical impulse. Normally, location area is fused intercostal space, right? But we have three characteristics: location, amplitude, and size. So if it's here, means that it's that the chamber is normal size and normal force. If you have it like this, the increased pulsation means that you have the increased force of construction, right? What does it mean? Hypertrophy. Hypertrophy. If the apex is shifted from the normal position, what does it mean? We have dilation. If we have the apex, that's how it's reaching out our surface. This way. This is the side of apical impulse. Or that could be the size, if you have a look over there. Or that could be the size. This is the normal size, how it's reached. And this is the size, how it could be reached. So this is dilation. When the apex is shifted. And when the apex is, the size is enlarged.
Increased.
So dilation, shiftness, and size. Force is just the amplitude with which you feel it. Okay? The same for right ventricle. If you see this force more harder, means that this is hypertrophy. If you find it somewhere here, means that the chamber is dilated.
What about the increase in size?
Sorry?
What about the increase in size?
Dilation.
Dilation. For the heart impulse, we don't find the size. We just have one position, whether we find it or not. I mean, for the right ventricle. And for the left ventricle, we have three positions: the location, the size, and the amplitude. Amplitude is force, hypertrophy. The size means dilation, and shiftness means dilation.
But then I would have thought that hypertrophy was like size as well. Like, I don't know.
You know, it's always very close. That's why,
Hypertrophy and then dilation.
no,
Dilation and hypertrophy.
No, hypertrophy and then
Then
dilation.
dilation.
yes, hypertrophy then dilation. Normally,
Compensation and
that's how it
decompensation.
goes. Just for you to understand, hypertrophy, when we check during the ultrasound examination, hypertrophy, when, for example, we check the width of wall, right, left ventricle wall. Normally, the upper range would be 9 millimeters. 9 millimeters. This is the normal range. 11 millimeters, which is plus 2 millimeters, that's already hypertrophy. When we have 13 millimeters, I always say that's a huge hypertrophy.
Okay.
So for the enlargement, just 3 millimeters.
Is hypertrophy. And for dilation.
We won't find it. I mean, those 3 millimeters we won't find as the shiftness. You
Oh, like that.
Yes.
Okay.
3 millimeters of the wall, like this, or like this. You won't find it, never, with the enlargement. So only when you count this, when you measure it during the ultrasound examination, or the force with which heart will be constructed. But when you have the diameter of the chamber, for example, 4 centimeters or 6 centimeters, that's dilation, and you can find
Of
it
the chamber.
of the chamber.
Okay. Okay. Now I understand.
All right.
What is the